Hello everyone, welcome to Geonodes Daily series where we do something cool in geometry nodes and we try to do it as fast as possible. And it has been a while since I show you how you can implement a formula with geometry nodes. So today we are going to look at the Quint Easing interpolation and something extra from the other interpolations that I done in the past. I added a factor in, factor out, so you can easily use that one with other presets, like the mix vector preset that was also used for this showcase you saw in the demo. That did the morphing between the spiral and the letter M. So as usual, if you find the content on this channel valuable, you can help it grow. You can help me by purchasing the gumroad project files, and the project file for this particular video, it's gonna look like this. You saw it earlier, and it has a bunch of control as usual for the number of particles and the particle scales, and of course you have a seed for changing their rotation, as you can see here, or the scale distribution. Also you have controls for the flow and wiggle speed, and that's something that you can see here, that motion of the particles. Apart from the morphing effect in itself, the particles are moving. So when you have the controls for the interpolation, the one that we are going to create today, by the way, this entire example, the morphing example, I'm going to show you tomorrow how you can build it. And at the end of the settings, you can control different settings for the two morphing stages, the text and the spiral, and you find it all here. So let's get started with the first point, explaining the logic of this easing interpolation. And for that, we are going to switch to a clean file that contains only the formulas. And we are going to talk about that for a bit. So when it comes to implementing a formula in geometry nodes, you will usually follow a few steps. One of them would be finding the formula in itself. Once you find that formula, if it's pure math, you have to transform it in some sort of a language that makes sense, pseudo language. If you find it in a certain language, like I did here, you have to make sure that you understand its syntax, and then the first step will be how to implement that formula. So you find the formula, you turn it into a logical language that can be implemented with nodes, and then you do the implementation in itself. So I found the formula for the Quint interpolation in TypeScript language, as you can see here. And if we read here, I found this description says, below you can see the code of the easing function written in TypeScript. The variable x represents the absolute progress of the animation in the bounds of 0, beginning of the animation, and 1, end of animation. And then you have function is Quint, and these are just something that I had because I pressed here accidentally. Function is Quint, and then you have a parenthesis here, x dots number, then dots number, and these commas, and this is the formula. So you can look at the online of the syntax of the program that you found the formula for, or if you know it, even better. But once you understand the symbols, you can look it up, and you don't have to actually be proficient at programming in that language. You just have to understand it to read it. then it's just a matter of implementing it. So basically, in this case, we have a variable x that will be allocated to another variable named number. And in this variable named number, you will get the return of some function. In this case, this function. Is the same for isOut. You get a variable, you get the result in the number for the x, and then you have to implement this formula. For the easing and out, it's a little bit more interesting because you get in this thing here. And what is this? Basically, it's a condition. You check that x is below 0.5 value, and if it's true, that's what the question mark says. If it's true, you do this formula, and if it's false, you do this formula. So basically, you have two formulas, one for x lower than 0.5 and another one for x higher than 0.5. So basically, this is what we are going to implement here, these three formulas. So we will start by implementing this easing function, that it's basically multiplying x like 5 times. So what will be our x? Well, it's a variable. So the question is how you can implement a variable in geometry nodes. So you can implement a variable by performing certain function on a mesh. For example, if we have this node set position, this is a node that tells geometry nodes, okay, do something for every vertex in this geometry that we have implemented here. So basically, when each vertex becomes a variable that you can use. You have a variable, and each vertex will give a value for that variable. So if we look at this spreadsheet, I switch it so we can see what's going on. Let's create some vertices, and for that we'll use a mesh line, and we can plug this one here. And now we have a count for the points. So let's say we want to have like 1,000 points. And now we have a line that goes on the z-axis. If we look at this, we have a line that goes on the z-axis like 1,000 meters up. But that's not what we want. Let's keep things easy to follow. So if we have an x, let's say that we want this line to follow the x. So let's put it like this, something like this. And instead of offset, let's do endpoints. And that's going to give us this interval that we want, the 0 to 1. We'll make sure that the x is going to be between 0 and 1, because we start at 0 and we end up at 1. So if we look at this point, and let's look at from the front, from the left, I think. No, actually, I think top. Yep. Okay, so now we have this line from 0 to 1, and we can now play with the points on this line. We have like 1,000 points here. You can use a curve also. So let's say we can use a curve line and do basically the same thing. That's gonna make things easier a little bit with the preset at the end, because we will have a spline to output from the get-go. But in this case, we have to use this resample curve, and now we can control the number of points here. So if we look now at these control points, we have 1,000 points from 0 to 999, and where X location is going to be a number between 1 for the last point and 0 for the first point. So basically, like this formula is saying here. So if we start to implement now the first formula, that is very straightforward. In this case, it's not complicated at all. We kind of have to do something with the position. We will going to accept the points on the z-axis. So let's do a vector, combine x, y, z, plug this one into the position, and now we can start to play with the things around here. So let's take a vector separate x, y, z. Let's combine everything here, and the vector we are going to use is of course the position of the points. So if we plug this one, we go back to square one. Now we have our points going back, but the things that we achieved is that now we can do a bunch of math here in this area here on a simple level. So now the x location is going to be our variable x, so we can do the easing function. So let's take a layout frame and call this one is in, and now we can simply take a node and we have x multiplied by whatever. So we need a math node. Let's plug it here. This is going to be our x, and of course we want to affect the z-axis, so let's plug this one on the z-axis, and we have x times 5 here, so we can do like power of x and exponent 5, something like this. So apparently nothing happened, but that's because we offsetted the points on the z-axis and we do not see the z-axis here. So if we switch to front, for example, we kind of see what's going on. We have our easing interpolation, and this exponent will control the curvature. So let's leave it like 5, the same it says in the formula. And now let's implement the ease out, meaning this part here. So let's simply duplicate these nodes here, and we of course we are going to use the same here. And now it comes the interesting part, because we don't have for example brackets in let me make it a little bit bigger, something like this, so we can see we don't actually have brackets in geometry nodes. So given the fact that the way the things gets calculated in geometry nodes is from left to right, yeah, I kind of have to be careful not to mess up things up here. And because of that, we have to make sure that we actually feed the information correctly here. So what do I mean by feeding the information correctly? Making sure that we do not give something to the geometry node that was not already computed. In order to create a parenthesis, we kind of have to most of the time go backwards. So for the power function, we kind of have to give it this result already calculated, and after we calculate the power function, we will do this subtraction, because otherwise we will end up messing things up. We will not get the correct results. So because we can't replicate other way the order of operation. So for this one, for example, we have this power node. Let's duplicate it, and let's do one subtraction. and from basically we need to subtract a power of x from this value. So let's do 1 here, and we need to do a power of amplitude 5. So we have it here, and then we kind of have to do 1 minus x here. So this is what we need to do here at the end. 1 minus x. So basically we kind of have to do this the other way around a little bit. We have 1, we have to subtract something. It's going to calculate the power of 5, and this result is going to be subtracted from 1. So basically we created this parenthesis by going backwards. I hope this makes sense. It's going to be more apparent as soon as we implement it in the final part. So now if we look at this from the front, we can see we have our formula here working nicely, and the exponent again will control the curvature here. So going to the third part, we kind of have to implement two functions here. We want to implement, let me make a little bit more room here. We want to implement a formula for x lower than 0.5 and another formula for x higher than 0.5. So let's do just that. Let's duplicate this frame, and I'm going to change its name, and then we will want to do another frame, this one, duplicate it and change its name. So now we can calculate for lower than 0.5 and higher than 0.5. And for lower than 0.5, we have this 16 multiplied by 1, 2, 3, 4, 5. So power of x, x at the power of 5, and then everything multiplied by 16. Given the fact that we have multiplication and power, we kind of have to make sure that we do this first and then we do this in order to not get weird results. So let me take a math node and take the x here, plug it here, and do this power of 5. And then we can duplicate this node and do multiplication with 16. So as soon as we do this, we kind of have this part. So let's do the other one, and then I'm going to show you how you can combine it. This is a little bit more complicated. So what we have to do, we have this 1, and from it we have to subtract this entire thing going on here. So we saw that we kind of have to go backwards for that. So the other operation would be to solve this bracket, and then the entire result from here we have to divide by 2, and then everything that is calculated here has to be subtracted from 1. So we basically have to start with this parenthesis. So we have minus 2 multiplied by x that we have to do. So let's do that first. Math here. And we have multiplication minus 2, and we have to multiply it by x, and then at this we have to add 2. So let's do this one. Let's say add 2, and we calculated this, and now we have to do a power at the exponent of 5. So let's duplicate this node, switch it to power, and put this on 5. So doing this, geometry node will start to calculate this node, then this node, then this node, and we basically recreated this parenthesis. And now we have to do the division first. Geometry doesn't know about order of operations, so we have to make it manually. So we will do this division by 2. We'll take the entire result that we get from these 3 nodes, meaning these parentheses, and we will divide it by 2. And as soon as we did this, we have this completely. So we kind of have what we need to subtract from 1. So let's do a subtract, and this result we want to subtract it from 1. So like you see, we kind of had to go backwards. If we would have put this one first, he would have not known what to subtract because nothing was calculated. But this way we calculated everything. Starting again, we took the brackets for the power, and we had this order of operation. We have to do first the multiplication, then the addition. So we did the multiplication first, and then the second operation was the addition, and then we did the power of this. And this is working because you can have another branch here of operation. If you have it, it will go just okay in parallel. And after we calculated this power function, we did the division by 2 here. And once we had this entire thing calculated, we could subtract it from 1. So how can we mix these two things? Well, we have this condition, x must be below 0.5. So we need to put a switch here, switch this one to float, and if the condition is true, we want to calculate this, and if it's false, we want to calculate this. And our condition, it's dependent on the x. So let's do a compare, and we are going to take the x value and say if it's less than 0.5, like in our formula, we get true, otherwise we get false. So now we have this calculated. So if we replace it here, we get our formula. Yay! Awesome. So now let's talk about creating the preset, because this is the cool part. And why it's cool? Because we want to create some outputs here. We will like to output on this one a spline. We already have this one. We would like to get a mesh, and we would like to get these points, and also a easy in and ease out. So for the spline, we already have this set up here. So let's just select everything here and give up of this frame and do Control J, and that's going to create our preset. Here, let's say GN is Quint. Excellent. So now if we look at this, we have this output. Press N and go to the group. We can rename this. Let's call this one spline. And now we can start to implement something else. For the edge, let's take this result and go to curve to mesh. And if we plug this one and we use no profile and plug this one here, we will get the mesh edge. Excellent. If we just tab out of this one and look at our result, we can use this mesh edge, and the output is going to be edge. And if we plug it here, it's going to be a spline. So how can we add the position of points? That's going to be interesting to add now. Let me save. We have to transfer the position of the points from our mesh to the output. So for that, we have a very useful node. transfer attribute that does just that, transfer an attribute. In our case, it's going to be the position. So we need a vector and we input the position. And then we have some ways to transfer the attribute. And we can transfer based on proximity, or we can transfer based on index. And we want to transfer based on index. So that's the most precise way to transfer when you have the same number of points on the input and output geometry. So now we can simply drag this one here and expose this parameter, and we can give it a name. We can call it points. Excellent. So now we have the ability to access the points outside. The interesting thing comes now to transfer the factor. So we can use it with other presets. So we can use this curve instead of a linear interpolation. We can use this one. And for that, we need to have a factor in and a factor out. So let's take the input, and we have it here. One thing that I like to do in order to clearly see my inputs is to give them a special color, like this one. So now I know that this is an input. And for the input, we can create a float input. Let's do plus, and we'll do factor in. So we know what this is. And the value will be default 0, and the range will be minimum and maximum. The geometry nodes accept hold infinity here. It's not infinite, it has a range, but it's okay for us. So once we have this, we can transfer this attribute. So what exactly we want? We want the values on the z, because this is the values that we calculated. So we can do Ctrl+Shift+D to keep the connection. We do a transfer attribute, and here we can do vector separate XYZ, take this one here, switch this one to float, and we can take this position. Ctrl+H to hide the sockets we don't need. So now, based on the index, we can simply transfer these points to the output. And for the output, we can drag this one here and call this one factor out. Excellent. And again, we have unlimited range of number. Every number can be used. So now we have this factor in, that we have to use it somehow to control the factor out. Right now we are going to expose all the points here. So let me look at this. We have this, so if we do Ctrl+Shift+Click and we look at this geometry, what we are exposing now is the Z location. But the factor, we kind of have to have something that allows us to move on this spline. So we can use the index for that. And the way to use the index, we kind of have to do a map range on this, and that was going to be plugged into the index. So for that map range, let's add this node. Let's call it a map range. And we will plug in the factor. And that can be a 0 to 1 factor. That's just fine. And the result will be plugged here. And now we want to remap a range of 0 to 1 to the number of points on our mesh, this index, 0 to 999. So in order to make it procedural and not to have to adjust more settings than needed manually, we can create an input. This is the number of points that we use, this count here. So if we output this one, and we look at it here, default it's 1, and we have a maximum. So if we exit this node, we have this control here for the count. And now we can use this count here in our group input. So we can, let's duplicate this one, take this one here, and now we have a count, and this will be our maximum. But because we have 1000 points that have an index from 0 to 999, we will have to subtract 1 point from here to have it precise. So let's switch to subtract, and now we have a correct mapping. So what this is going to give us, right now we see we have an output of 0. So let's come out of this node. If we look here and we do again a viewer node, we have a 0, but when we start to play with this, we basically follow our interpolation. But you see something happening when we go below 0 or when we go above 1, we stop at the 0 to 1 interval. So this is clamped to the 0 and 1 interval. And we would like to have an infinite factor control. So how can we do this? We have to find a way to loop this interval in the 0 to 1 range. So how can we do that looping thing? Well, we want to detect when this factor is above 1 or below 0. And if it's above 1, we want to add to the result that we get here. This result here, we want to add, let me delete this node. We want to add to this result 1. So when the factor will be 2, we want to add 2. 3, we want to add 3, and so on and so forth. And how can we do that? Well, we have this factor in, and we want to do something to it to make it snap in one increment of 1. And then we have to take the result from here and add to it this value. And now we can output this result here. So once we do this, let's come out of here and look at this output. Again, I'm gonna click it like this. And if we start at 0 and we go, we see the value growing, and we go above 1. And now we have this value that is stuck here like this. So it's not exactly working because we have to do some other things now. So let's go inside of here and see what else we have to do. Why do things get stuck when we go about these values? Because as soon as we pass the value, this node being clamped and the index being between these two ranges, we will just get to the final point and get nothing else. We kind of want to loop this input also to make it go in the 0 to 1 range, 0 to 1 range for infinity. And in order to do this, let's add a modulo function with value of 1. So now we can basically loop the input when it goes above this value. So now if we look at this output and we start to play with it, we can see surely enough that we get the result that we wanted. But that's not all. It's good to check it, because as soon as we go below 0, something else is going to happen. Check out this. We get the same problem. As you can see. So how can we fix that? Because this is modulo is not going to work for the negative values. So we can do something with that. Let's move this a little bit here, and let's add another math function, and this time we will add an absolute function that will turn this input into a positive value no matter if we go up or down, below or above 0. So now if we play with this value, as you can see, it's working, but we lost the sign, because when we go negative now, we still have positive values. So how can we fix that problem? Well, we kind of have to check for the sign after we do all this changing here. So the way we can do that, we have this factor in, and again we can use a multiplying, so we can take the result that we got here after we add it, and before outputting it we want to multiply with -1, so with negative, and the moment we go on the negative value. So how can we do that? How can we know when we are negative here? Well, that's easy. We can take this input here, and we have a very nifty handy function called sign. So this is going to return 0 when the input value is 0, and -1 when the value is below 0, +1 when it's above 0. So basically that means that we multiply this result that is always going to be positive with -1 when the input factor is below 0, or with 1 when it's above 0, and with 0 when it's 0. So things will just work fine. As soon as we come out of here, if we look at our result, things looks nice, and if we go on the negative value, we get our sign. So here you go. This is everything. Before we close, I want to show you the nicely organized node tree. This is how you will find it in the project on Gumroad. I'm gonna quickly show you in case you decide not to purchase this project. You can look at this screenshot and recreate it at your own pace. So we have the easing function, the ease out function. We have the two formulas for ease in and out below 0.5 here and above 0.5. We have this switch that allows us to combine those. What is extra and I didn't do, I created this way to swap interpolation because we have a bunch of things exposed. I'm going to show it to you. But basically we have an exposed value that allows us to decide if we want the ease in function, the ease out function, or the ease in, ease out function. And that's working with this switch here. As you can see, we have the switch for the ease in and out function, or the switch for ease in or ease out. Switching between this and this is here, and switching between these two options and this one, it's here. And we have here the line that we created, and we have this set position here. One something that I added here is pinning the first and last points to make sure that they don't go out of the 0 and 1 range. This will be our graphic. We have the first point here at 0, the last one at 1. And I wanted to make sure that no matter what you do inside here, the first and last point will stay put. Otherwise, when you use in certain projects, you can get unexpected movement. And what I did in order to get that, was taking the x value that we use throughout the entire project and checked if that is equal to 0 or if it's equal to 1, and that gave me the mask. And what I did then was for only those mask points, I just used the original x value, not the one that we modified with our formulas, to make sure that points will stay put. This is the factoring control that we did earlier, and it's just the same thing that we created. This is putting the sign, looping in adding the values when we go above 1 or below 0, and these are the exposed value. And of course, we have this frame that shows the formulas. So here you go. This is the preset. You can recreate it exactly like I did. And if we just do this, going out of this and looking at this function, that we have here, as you can see, if we look at just this, we have for this preset the factor in that we can use, resolution, ease out, allowing us to switch to ease out instead of ease in. We have the ability to play with this preset. So if I'm just gonna hide this and just look at this, we have this preset. So we can switch between ease in and ease out. We can play with the amplitude as much as we want. It's working just fine for both ease in or ease out. Or we can switch to ease in and ease out. And again, we have an amplitude in and amplitude out that is exposed. So we can do some tweaking to those values. And those were implemented here. As you can see, exposed as amplitude, and for this one, amplitude in, amplitude out. So this is it. Thank you very much for watching this tutorial. Again, it was a lengthy one. For the next interpolations, I'm just gonna refer to this video. I'm not gonna recreate this all the time, but I am going to show you how I created the demo video tomorrow. The demo video that you saw at the beginning. Until tomorrow, have a nice day and happy